Right. Hello, everybody. My name is Rodolfo Lossio. I'm a PhD engineer for Infineon. And today, I'm going to talk about our newest microcontroller called PSOC Edge. It went to full market launch a few weeks ago, so it's something pretty new. So we also prepared some demos. We don't have a booth here, so that's why I'm going to show the demos here in this presentation. Besides the microcontroller, we're also going to talk about our AI solutions and software tools we prepare to work with this microcontroller. So we know that AI is changing a lot the world. It's enabling a lot of innovation in our products, in our life, allowing like new use cases, boosting efficiency. We can do things faster, and it also improves our decision making. So it changed the way we work, the way we produce goods. We see in factories now we're using a lot of robots, industrial automation that use some sort of AI to speed up how we produce the goods. And it changed the way we live. For example, sometimes we even don't need to drive our cars because they can drive by themselves. The way we interact with each other, it's also changing. Sometimes we even don't know if you're talking to a person or to a machine because things are changing pretty fast. So here there's some marketing material. We saw that AI is not something only running on cloud or on data centers. We are seeing a trend where a lot of things are moving to the edge, to the device part. And we are seeing a growth of 32% every year on this market. And there are a lot of benefits to run all this AI capability on the edge. First, you might not need like internet connection, or you might not need to have like a very fast connection to send so much data to the cloud, raw data. You can do a lot of processing on the edge. So you might save on subscriptions. We might even simplify your hardware, not requiring connectivity. And then you have all this AI workload working on the edge. Also, because you're already on the edge, you can do real-time operations. So the latency to get the results are much faster. And you might not spend all the time to transfer data to the cloud. And all these savings you have on the time can be used for processing things on the edge. And then that means you're going to reduce your power consumption, roughly like by 50% in our estimations. There's also the security and privacy issues. For example, when we start seeing the smart speakers on our house, like in the beginning, they are actually streaming all the audio data to the cloud. So like the device is listening to people talking because everything was processed in the cloud. Now we have the possibility to do all that processing, all that audio data on the edge without like transmitting any data to the cloud. So that also addresses some of the privacy and security issues. Even the data, we no longer need to send somewhere else. We process the data in real time, and as soon as we process, we can destroy the data. So there is also a security issue addressed here. And you're seeing a lot of areas here where they're using HAI. And it's not only about consumer devices, but also manufacturing, transport, logistics, and smartphone. All right, so what Infineon can offer on this field? So we have created a solution called DEEPCRAFT AI Suite. It includes not only hardware, but also software tools. And I'll also have different flows. For example, we have a flow where you bring your own data. So for this flow, it's usually for companies or developers that they don't have machine learning expertise or AI expertise, but they have data, but they don't know what to do with this data. So we have a solution where you can bring your data and it can create an AI model for you to run on our hardware. So for example, you're an audio company, you record audio, and you have collect a lot of data. And you have like data about the environment, like traffic and office, you have all this data, and you want to do, let's say, classification to determine what kind of noise is in the environment. So you can get all this data, upload in our tool, and you can generate a model for you that will classify what kind of noise is in the environment, for example. Now, let's say you're an expert in machine learning and AI, and you know what you're doing. You're familiar with those like TensorFlow or PyTorch frameworks, where you can create your model, and you have a pre-trained model. So how can you deploy that to our device? So we have another tool that's used for this kind of expertise, for people who actually know how to deploy, how to generate the pre-trained models, how to run the training and everything. And another use case is like you don't have any expertise. You don't have data, you don't know machine learning, but you'd like to use machine learning somehow. So what you can do, you can bring your own use case and use one of our ready models. We have a bunch of solutions you can run out of the box without any expertise. So, for example, using audio, we can do like a baby crying detection. So they create a product to detect a baby's crying, so you can alert someone. Or like you're sleeping, you want to see how long you snore during the night, you can measure the time for you. But for vision applications, you can detect people, count people, do object detection. So we have a bunch of solutions ready to be used and deployed in our hardware. So our DEEPCRAFT AI Studio AI suite, we have like the software, the solutions, the hardware, and even a community where you can share your experience. And then in terms of tools, we have DEEPCRAFT Studio. This one is used to bring your own data. And hopefully then I can quickly show the tool if I have time. And then I have DEEPCRAFT Model Converter that's used for bring your own model. And then you have a website where you can shop for our solutions. All right, so let's talk a little bit about DEEPCRAFT Studio. So this tool, as I said, you need to bring your own data. You can also use the same tool to actually capture some data. So we help you to collect the data as well, the data acquisition part there. When you're acquiring data or when you're importing data, it's very important that you also label the data. You need to not only provide the raw data, but also classify the data, label saying, okay, if it's audio data, this type of noise, it's a certain type of noise, and you need to label that noise, that information. So our tool helps to do this labeling as well, in case it's not labeled yet. And then once you have the data, it's a labeled data, you need to define what kind of pre-processing you want to run. So this is the important part. Usually when you run AI models, you don't use raw data. You need to to do some manipulation. So I like to give that audio example because it's a good target for us. So for audio application, raw data is in integers, like a wave, and it's in the time domain. But when you run an AI model, usually you do some transformation to more frequency domain. So you might do like a Fourier transform, so some mathematical manipulation of the data to reduce the amount of data, still representing the raw data, but in a different way, in this case in the frequency domain. And then you can feed to your AI model. And then you can run more efficiently and faster. So we have a list of algorithms you can use, not only for audio, but also for other types of time series data, also for vision. And you can just choose, like we have a list of options that you can just choose in our tool. All right, so now we have the data, you have the processing data, and now we can feed that on a model. Now the model, you can create one from scratch if you have that knowledge. So you can use our tools to say what kind of operators you want to have in your model, how many nodes, or you can use one what we call starter models. So our model is specifically designed to solve a certain problem. Audio for vision, for example, YOLO type of model for vision. And then for audio, we can use other models for classification, like deep neural networks, for example. So you can choose the model if you know how to create from scratch, and then use all the data pre-processing to train the data. So when you have the data, you also can split the data in training data, validation, and testing. And then we do the training for you. In most of the cases, you even don't know how the model looks like. Although you can see it, but you don't care. You just want to get the model, the final results. And then once we complete the training, and by the way, when you do the training, training is something we don't do on the edge. We want to do in the cloud because you need a lot of data and a lot of processing power. So training is usually something we do in the cloud. So when you use our tool, what you do is we upload all your data to the cloud, run the training on the cloud, and then after the training, how you generate the model, you just store your data. So your data is still secure, and we're not going to store on our servers. But after you do the training, what you get is the model, and then we provide the model evaluation, and we generate some reports like F1 score, the matrix confusion. So those are some reports to say how accurate is your model. And you also can provide some optimizations, like a quantization, for example. When you have a model float point, I want to do conversion to integer. And then we generate a C code in a library, which you can deploy in our microcontroller, the PSOC Edge, which has some hardware optimization to run AI models, which we're going to talk about later. So we have two evaluation kits you can use. One is called PSOC Edge Evaluation Kit, and the PSOC Edge AI. So this is a general purpose with a lot of resources here. It is a display and so on. And then the AI kit's a much cheaper one. And I'm going to show both later and talk a bit more what they have in there. All right, so now let me talk a bit about the solutions we provide. So as I said before, we have some solutions ready to go that we call the DEEPCRAFT ready models. So those models you can use out of the shelf, and you deploy directly on the PSOC Edge device without any expertise in machine learning. So some examples, we have the baby crying detection, cough detection, direction of arrival. That means you can detect, we have an array of microphones. You can detect the sounds coming from north, south, east, west, southeast. So there are eight possible directions. We have factory alarm detection, serene detection, and snore detection. So those are all based on audio streams. And then you have one that's fall detection. That's for maybe for a device for elderly people, like to fall on the floor, so we can detect that and send a request for help. So that one, you use a motion sensor, for example. And then we have one that's gesture detection. This is using radar. So Infineon also sell radars, and we can use that as a method to detect gestures. Even if you can detect your vitals, like your breathing or your heartbeat, it's still possible. But as a ready model, we have one to just do gesture detection. So you can see do some gesture, we can detect that. We are also working on something that we call language models. So this is, I would say, like it's a mini ChatGPT running on the edge. I mean, ChatGPT is general purpose, or you can say whatever and we got a reply. What you're talking about here is something more narrow, where you can use, like, let's say, you create a product. There's a documentation of your product. So your documentation is your input for this model, and then you generate a model that can reply questions that the answer is in this manual. So we can narrow down like what kind of answers you can get. So this is coming, and it's already in. All right, so that's already models. Another thing we have is the DEEPCRAFT voice and audio solutions. So we have two here. One is called voice assistant. So the voice assistant, it helps you to define commands you want to detect. So you can talk to a machine, and then the machine will detect if you say certain commands. So it's a little bit different from the language models here. That is more like a ChatGPT style. This one is like you need to write down all the commands you want to detect, and you just see the person spoke that command. So, for example, I want to talk with my watch and say, "What time is it?" But I can say what time is it in different ways. I can say what time is now, or I might use a different expression. So you need to write down all the possible ways you want to ask that question, and then you put in your tool, and then you generate a model that will detect all these variants you define. And hopefully, I will also show how this tool works. The tool itself, it's a cloud-based. So you go to a website, create all your commands, and then you generate a code that you can deploy in your device. And then interesting, the modeling, it runs on the device. Then another solution we have is the audio enhancement. So audio enhancement is pure for noise reduction on audio stream. So we apply a few algorithms to do noise suppression, informing. So when you want to direct which direction you want to suppress or increase the gain of the sound. So the way we do this audio enhancement, we just give the voice spectrum. So anything that's outside the voice spectrum is reduced, and then you can only listen to clear speech. And this works nicely with the voice assistant, because the voice assistant, you need like a very clear speech to work well. So applying the noise suppression algorithm and the audio enhancement will help to reduce the speech. So these are our voice and audio solutions. Then we have the vision solutions. And then as an example, we do like object detection, person detection, and FCD. And that FCD I'm going to show later on our website. All right, so let's talk now about our microcontroller. So we designed PSOC Edge specifically to run these AI models. And then there are a bunch of applications you can use. So like for monitoring vision, smart homes, wearables, that's a big thing for us. We are very power efficient comparing to some competitors, some next door. HMI devices, and even on industry, on factories, like using robots, also it's another possible application. So we designed specifically for low power. So it's normal to see us on battery powered devices. And then we have the DSP capability and NPU as well. And the neural net processing, I learned a bit in the previous presentation. We also have a rich user experience. So we have a GPU and a display controller, and then you can interface also microphones and cameras. We have the highest level of security in the market. We are PSA certified L4, and that's the highest you can get right now, microcontrollers. And then we already talked about the software tools here. All right, so what's inside of PSOC Edge? So it's a dual core device. It has the M55 running at 4 megahertz and the U55, which is our neural processing unit, and also at 400 megahertz. And then the M55 supports hidden DSP for general digital signal processing operations. And then you see the cache. We have a ITCM. TCM, it's a tight couple memory, so we can put critical code there to run faster. And then this is our high performance domain. So you can see a lot of other microcontrollers now with this. But one special thing we have is the low power domain. So this is specifically to run workloads for that doesn't require too much power. And we all even have a neural net processing unit for this. It's called an Light. So it's much smaller than the U55, consumes way less power. However, there's a restrict number of operators who support it. So this will not be able to use for vision, but you could use for audio or for motion detection. So there are some applications that you definitely need to go and then this device, it uses external memory. So we have 2 serial memories here you can use. So usually you have one for non-volatile memory, like flash, NOR flash, and one for volatile, like PSOC. And we don't have much internal memory, internal non-volatile memory. So we kind of have to use external flash. And that's good and bad. The good thing is we can scale the application. So in case if you need a lot of memory, like when you run AI models, you never know. It could be like a massive model, it can be a tiny model. So if it is a lot of memory, you can just leverage external flash rather than choose like a different device. We just select a bigger flash memory, external flash memory. But we do have a lot of SRAM. So our system SRAM, and called SOCMAP. This memory is up to 5 megabytes. And that's usually used for the high performance domain. And then the low performance domain, you have 1 megabytes to work with telemetry. And then we have an internal RAM. This is a non-volatile memory. That's usually used for most of the memory is used by the secure enclave. But there's still can write some code there for the application. And then we have all the good stuff typical microcontroller have, like all the peripherals here, USB, I3C. We have something called SCB, serial controller block, where you can implement I2C, SPI, UART. We have Ethernet, CAN for automotive market. And then for human-machine interface, we have a TDM I2S for audio codecs, microphones, analog and digital, and the GPU there as well. And then here are the features we have for the secure enclave. We have curved accelerator, OTPs, degree starter. And then we have general system controls like PWMs, counters, blocks, and so on. And PLL. There are 3 PLLs in the rest. Yeah. All right, so now I'm just going to give a quick introduction about our EVK. So this is our most expensive EVK. This might cost almost $300 because it has a display. There's a 4.3 inches display. There's even a camera. This is a USB camera. So here's the USB connector host. So we use a USB camera to do whatever. And the black part is our baseboard, and then we have a SOM, the system module, which has all the major devices. The PSOC edge is there, and the memory device. We have 60 megabytes flash memory and 60 megabyte PSRAM. We have also a PSOC 4 there that's used for capsings, for capacitive touch. We have some buttons here that you can press using capacitive, not mechanical. And then also in the SOM, we have Wi-Fi and Bluetooth combo chip, so we can have connectivity there. And there's a speaker here, so we can play something. And then you have 4 microphones. You have 2 analog microphones here in the bottom and 2 digital microphones. So now we're going to run a demo since we don't have a booth. And I'm going to set up a camera here so everybody can see what I'm seeing. I hope this will work now. All right, so I have a webcam. All right, so this I'm just showing the display from our kit right here. So that's our box. You can buy it today. It's available. You can go to our website or a distributor. It's almost $300. But we later going to talk about one that's much cheaper. But this is more evaluation kit for like we might give this kit if the customer is a big one. All right, so let me show you how it works. So this is when you buy this kit, that's why you're going to see it. This is our out-of-the-box experience firmware running there. And you can choose multiple applications here. All right, it's changing the color here. Anyway, so it's a third screen display, so I can use my finger to change which model, which demo I want to use. So I'm gonna play the music player first. So I have there's a speaker in this EDK, but it's not very powerful. But I hope you guys can listen. So the nice thing about this one, it's we can do voice control. So here are the commands I can say, and then the device is always listening for the wait word okay infinite. So every time I say that word, you're going to listen some commands, and then if I say one of those commands, he will play. So for example, okay infinite, play music. So right now the volume is level 2, so I'm going to increase the other the volume. Okay infinite, set volume. Okay infinite, set volume to level 5. Right now it's louder. And we also have, as I said, we have audio enhancement. One of the features of our audio enhancement is the acoustic echo cancellation. So while you're playing some song in a loudspeaker, we can cancel that. And the microphones you're capturing, we compensate that and basically cancel that, and so you can hear my voice. So I can say, okay, infinite, next track. So he still can recognize my voice. Okay, infinite, go to home screen. All right, so another demo I want to show is the rock and paper scissors detection. So this one, I can do some gesture here, the paper, scissors, or stone, or rock. Oh, it's rock, yeah. So that's another thing you can do on the device. And the last one is the Face ID, which I think is the coolest one. So this one, I can register my face. And so right now I'm unknown because it's not registered. So I can enroll. And then press this start. And then look at the camera. Look up. Look right. Look left. Look down. And now I'm a user 1. And then if someone comes here, it would be unknown, right? So I'm here, I'm user 1. This demo cannot run up to 5 people. To enroll 5 people right now. All right, so that's the demos on the show. And then the other kit we have is the EDK. It's this one. This is much cheaper. This is only less than $50. And it doesn't have a display. But there's microphones here so we can run. Or I don't have much time, but we could run something like the music player, for example, to detect voice commands. Now, one thing I quickly want to show is our voice assistant solution. So here is an example for a project where you want to define commands to detect. So here you can say which keyword you want. So in this case, a infinite, but you can choose an interjection. You're like, okay, hello, hi, mine. And enter the name, the wake word. So in this case, it's infinite, but you can say a watch or a television or something else. And then you have the commands here you need to write down. So we have different nodes. There's a wake word node, a text node, a variable, and intent. So you can drag and drop and create your commands. And then you might say different things, like to turn on the light, you might say lights on, or switch on lights, or turn on lights. So you can just fill up all the possible ways to say the command, and then we can detect all the possible variations. And then I also want to show quickly our DEEPCRAFT Studio. This would take hours to show all the features, so we're going to just do a quick introduction. So here's the data. So in this case, this is to detect persons, people. And then you can import your data. So here we have just like a cat, so it's not a person. And then you also can do some augmentation, like to flip the image or add some noise. But if you have like a picture of a person, so you need to label the person. This is a person. Oops. And then later you can run the model on the device here, and then see how that behaves, the model. And then if you're happy with the results, you can deploy on the PSOC edge and run something similar to do the rock and scissors. Like the same infrastructure that we built for that demo can work with your data, the way you label, and then run the training, deploy on the device. So everything is done on this tool here called DEEPCRAFT Studio. And then the last thing I'm going to talk about is the DEEPCRAFT AI Hub. So here you can go and shop for all our possible solutions you can run in your device. And that's it. That's what I have to present. Thank you, everybody.